As I mentioned last episode, and I'll just tell you right now again, the brain is incredibly plastic from about birth until about age 25. And then somewhere about 25, it's not like the day after your 26th birthday, plasticity closes. And humans do not like this feeling of frustration and making errors. The few that do exceedingly well in whatever pursuits they happen to be involved in. The ones that don't generally don't do well. They generally don't learn much. And if you think about it, why would your nervous system ever change? Why would it ever change? Unless there was something to be afraid of, something that made us feel awful will signal that the nervous system needs to change, or there's an error in our performance. So it turns out that the feedback of these errors, the reaching to the wrong location, starts to release a number of things, and now you've heard about them many times, but this would be epinephrine. It increases alertness. Acetylcholine, focus, because if acetylcholine is released, it creates an opportunity to focus on the error margin, the distance between what it is that you're doing and what it is that you would like to do. And then the nervous system starts to make changes almost immediately in order to try and get the behavior right. And when you start getting it even a little bit right, that third molecule comes online or is released, which is dopamine, which allows for the plastic changes to occur very fast. Now, this is what all happens very naturally in young brains, but in old brains, it tends to be pretty slow, except for in two conditions. So let me just pause and just say this. If you are uncomfortable making errors and you get frustrated easily, if you leverage that frustration toward drilling deeper into the endeavor, you are setting yourself up for a terrific set of plasticity mechanisms to engage. But if you take that frustration and you walk away from the endeavor, you are essentially setting up plasticity to rewire you according to what happens afterwards, which is generally feeling pretty miserable. So now you can kind of start to appreciate why it is that continuing to drill into a process to the point of frustration, but then staying with that process for a little bit longer, and I'll define exactly what I mean by a little bit, is the most important thing for adult learning, as well as childhood learning, but adult learning in particular. Now, the Knudsen lab did two very important sets of experiments. The first one, which showed that juveniles can make these massive shifts in their map representations. They get a lot of plasticity all at once, and it happens very fast in the period of just a couple days. In adults, it tends to be very slow, and most individuals never actually accomplish the full map shift. They don't get the plasticity. Then what they did is they started making the increment of change smaller. So instead of shifting the world a huge amount by putting prisms that shifted the visual world all the way over to the right, they did this incrementally. So first they put on prisms that shifted it just a little bit, and just like 7 degrees, I believe was the exact number. And then it was 14 degrees. And then it was 28 degrees. And so what they found was that the adult nervous system can tolerate smaller and smaller errors over time, but that you can stack those errors so that you can get a lot of plasticity. Put simply, incremental learning as an adult is absolutely essential. You are not going to get massive shifts in your representations of the outside world. So how do you make small errors as opposed to big errors? Well, the key is smaller bouts of focused learning for smaller bits of information. It's a mistake to try and learn a lot of information in one learning bout as an adult. Now, there is one way to get a lot of plasticity all at once as an adult. There is that kind of holy grail thing of, getting massive plasticity as you would when you were a young person, but as an adult. And the Knudsen lab revealed this by setting a very serious contingency on the learning. What they did was they had a situation where subjects had to find food that was displaced in their visual world, again, by putting prisms, and they had to find the food, and the food made a noise. There was a noise set kind of the location of the food through an array of speakers. Basically, in order to eat at all, they needed plasticity. And then what happened was remarkable. What they observed is that the plasticity as an adult can be as dramatic, as robust as it is in a young person or in a young animal subject, provided that there's a serious incentive for the plasticity to occur. And this is absolutely important to understand, which is that how badly we need or want the plasticity determines how fast that plasticity will arrive. This means that the importance of something, how important something is to us, actually gates the rate of plasticity and the magnitude of plasticity. And this is why just passively going through most things, going through the motions, as we say, or just getting our reps in, quote unquote, is not sufficient to get the nervous system to change. If we actually have to accomplish something in order to eat, or in order to get our ration of income, we will reshape our nervous system very, very quickly. And so I think that the studies that Knudsen did showing that incremental learning can create a huge degree of plasticity as an adult, as well as when the contingency is very high, meaning we need to eat, or we need to make an income, or we need to do something that's vitally important for us, that plasticity can happen in these enormous leaps, just like they can in adolescence and young adulthood. That points to the fact that it has to be a neurochemical system. There has to be an underlying mechanism. All the chemicals that we're about to talk about are released from drugstores, if you will, chemical stores that already reside in all of our brains. And the key is how to tap into those stores. And so we're going to next talk about what are the specific behaviors that liberate particular categories of chemicals that allow us to make the most of incremental learning and that set the stage for plasticity that is similar enough or mimics these high contingency states, like the need to get food, or really create a sense of internal urgency, chemical urgency, if you will. Today we're really talking about how to tap into plasticity through the completion of a task or working towards something repetitively and making errors. The ultradian cycle says that for the first 5 to 10 minutes of doing that, your mind is going to drift and your focus will probably kick in, provided that you're restricting your visual world to just the material in front of you, something we talked about last episode, somewhere around the 10 or 15 minute mark. And then at best, you're probably going to get about an hour of deliberate kind of tunnel vision learning in there. Your mind will drift. And then toward the end of that, what is now an hour and 10 or hour and 20 minute cycle, your brain will start to flicker in and out. You're trying your best to accomplish something and you're failing. You want to keep making errors for this period of time that I'm saying will last anywhere for about 7 to 30 minutes. It is exceedingly frustrating, but that frustration, it liberates the chemical cues that signal that plasticity needs to happen. And it is the case that when we come back a day or two later in a learning bout after a nap or a night or two of deep rest, then what we find is that we can remember certain things and the motor pathways work. And we don't always get it perfectly, but we get a lot of it right, whereas we got it wrong before. So that 7 to 30 minute intense learning bout, specifically about making errors, I want to really underscore that. And it's not about, as I mentioned before, coming up with some little hack or trick or something of that sort. It's really about trying to cue the nervous system that something needs to change, because otherwise it simply won't change. I think everyone could stand to enhance the rate of learning by doing the following. Learn to attach dopamine in a subjective way to this process of making errors, because that's really combining two modes of plasticity in ways that together can accelerate the plasticity. In other words, making failing repetitively, provided we're engaged in a very specific set of behaviors when we do it, as well as telling ourselves that those failures are good for learning and good for us, creates an outsized effect on the rate of plasticity. It accelerates plasticity.
Thanks for watching. If you found this information helpful, be sure to like, share, and subscribe for more health and wellness tips.